Okay, let's have a look at a practical transposition question. So this is a view from above looking down. It says if the area of the shaded strip, so the area of this bit, is 60.044 metres squared, what is the radius of the large circle? So this radius here. So the radius, of course, is a length. So you know the radius of the small circle, it's 7 metres, but you don't know the radius of the large circle. But you do know the area of this shaded bit. This is quite awkward, really, to solve if you're not familiar with this kind of problem, because a lot of rearranging and looking at it logically needs to take place. Well, it's a rearranging question. We need to find the radius, and we know that the area of a circle is given by pi r squared. Now if we know the area of a circle, if we rearrange this to get r on its own, well, pi times r squared, it's easy to get rid of the times bit, we take it across, so you get area divided by pi equals r squared. To get r on its own, if it's been squared, take squared across, it becomes square root. Now all that's already there, so all that gets square rooted. That's all well and good. We know what pi is. It's 3.142, whatever your calculator says. We don't know what the area is, but if we did, we'd be able to find out what the radius was. Now we need to find the area of all this big circle. So pretend this isn't there at the minute, it's just a big circle like that. What's its area? Well, if we know the area of the circle inside, and then we add on the area of the strip around the edge, that must be the area of all of it. So, let's do that. So the area of the small circle plus the strip must be the area of the big circle. So the small circle, well, if area is pi r squared, we know that the radius is 7. So pi times 7 squared, that's the area of that, plus the strip area, 60.044, gives the area of the big circle. Now, the area of the big circle in this case, let me get my calculator. So 49 times by, is there a number for pi? I can't see it. I'll do 49 times by 3.142. I know it's 153.958. That's metres squared. Oh, sorry. My mistake. That's the answer to that bit. 153.958 metres squared. Plus 60.044. So if I add on 60.044 equals 214.002 metres squared. Well, remember, we wanted the area to then divide it by this to get the radius of that outer circle. So what we've effectively done is we've managed to get the total area of this big circle, which is that. But now we want to rearrange the formula for area to get just the radius on its own, which was the original question. So, we've already got the formula. So if the area divided by pi, so that's the area, divide it by pi and square root it. That'll give you the radius. So in our case, we've got 214.002 divided by 3.142, that's divided by pi. And then I need to square root that answer. And I understand on these calculators I do inverse squared. No, that didn't work. Oh, it's square root there. So what did I have? 214.002 divided by pi equals, square root that answer, 8.253. So the answer so far, it's unchecked, is what is the radius of the large circle shown? Well, the small circle is 7 metres and the large circle is 8.253 metres squared. Sorry, that's not metres squared, that's just linear metres. If you walked from there to there, you walked in a straight line of 8.253 metres. It's not metres squared, it's metres. Alright, to quickly check that then, if we work out big circle minus small circle, that must equal this strip of 60.044. So big circle, pi r squared. So 8.252, if I square that and times it by pi, 214.002, which is what we've got before. And then if we deduct 153.958, then of course we know from these numbers here that will give us 60.044. So it works forward and backwards. We've got some confidence that that's the correct answer. Let's have a look at another problem different to that, involving a cylinder rather than a flat piece of area. So if the volume of a cylinder, so let's draw a cylinder, that's it in perspective, so it's like a toilet roll tube. The total volume is 345,245 millimetres cubed. Any units that you see cubed, metres cubed, feet cubed, whatever, just means that you're talking about a volume, you're talking about a 3D solid. Obviously if it was millimetres squared, you'd be talking about an area, and if it was just millimetres, you'd be talking about just a length. So in this case, 345,245 millimetres cubed is the volume of this object. We know it's 200 millimetres long. What's the radius? So it's similar to the last problem. It's basically saying, what is that distance there? What's the radius of the cylinder? Consequently, we're going to need to know a couple of formulas. Firstly, we're going to need to know the area of a circle, pi r squared, and to get the volume of a cylinder, it's that area times by its length, or in this case its height, or whatever that's the circle multiplied by the distance it acts over, which is 200. Fair enough? So let's rearrange now, then we'll chuck the numbers in. So volume of cylinder equals area times length. So volume of cylinder equals pi r squared, which is the area, times by the length of 200. Well, we're told the volume. The volume's 345,245. So substituting that number for that, 345,245 was created from doing pi r squared times 200. Strange, because we've already got the answer, if you like, and we're trying to work out what was the radius to get that answer. Well, the easiest thing to do really is, I could do it in one quick move, but I'll give you the full explanation. That's the same as putting 345,245 equals pi times r squared times 200. It doesn't matter which way around you have these. You could do r squared times pi times 200. It's like saying 2 plus 3 plus 4. It's the same as 4 plus 3 plus 2. 2 times 3 times 4 is the same as 4 times 3 times 2. It doesn't matter the way around because they're all being timesed. Consequently, we could write it r squared times pi times 200. It doesn't matter, but you have to have some mathematical knowledge or appreciation to appreciate that. Now that I've told you, you should know this. Now what we can do is, to get r on its own, we could do with getting rid of the pi and the 200. And if we write it that way around, we can just grab all of that, and then that times will become a divide. And we take it across, we'll end up with 345,245 divided by pi times 200. That times needn't change, because effectively this is in a bracket. You've grabbed it all and put it all over. It's that one that changes to a divide. That leaves you with radius squared. Well, the opposite of squaring is square root. So square root everything that's already there. So square root of 345,245 divided by pi times 200 will give you radius. Fair enough? Let's look at that on a calculator. So 345,245 divided by, I'm going to open a bracket, pi times 200, close bracket, equals 549.403. But remember, we've got to square root that. So if I square root that answer, I get an answer of 23.439. This is in millimetres, remember, this is linear millimetres. But it asks for it to the nearest whole number, so in our case it would be 23 millimetres. So, what that's saying is, a cylinder that has a radius of 23 millimetres, that's 200 millimetres long, will have a volume of 345,245 millimetres cubed. So we've started with the end in mind and worked backwards to work out what the radius was in the first place, which is a practical application of transposition. Thank you.